To welcome you in Prague. I'm very happy that we meet again, even in this difficult situation. And but as you see, we are not only the two of us here, but there are people online connected, so the audience is pretty good. So thank you very much for coming.
Červeně. To je dobrý signál, že svítí červeně.
No, asi došly baterie.
No, to je. Hello everyone, test of the radio. Can you hear me? Okay. So once again, thank you for this opportunity to present to you a little experiment we did with the very first version of CorefUD 0.1. Before this talk, we also managed to run the experiments with the almost ready version 1.0. So you will see the first preliminary experiments with the not yet released version of CorefUD. Okay, so now it's not skipping slides, but okay, I will manage it. Yeah, so I think it is not really necessary to present to you what this coreference resolution task is about, because you know it much better than me. Just maybe to remind some of the listeners that it is the task to find language expressions that refer to the same real-world entity. There are some examples. For example, Peter lives in London, and Steve lives in London, and in this case, the London is the same entity. It means the same thing. The more complicated example is this apple is mine, don't eat it. And here the it refers to the apple, so it's the same case. And the last example is the most difficult one among these examples. Is Mary gave Peter an apple, Steve gave him another one, and Peter took them and left. And in this example, an apple is a mention. We will use the term mention in this presentation. Steve gave him another one. This is another mention, but these two mentions are not coreferential. This is a different apple. They do not refer to the same entity, but Peter took them and left. The word them refers to both of these entities, and this is a coreferential relation. This is an example of split antecedent. So you see that the word them refers to two different expressions, even in different sentences. Maybe I'm telling something wrong in these linguistics terms, so feel free to correct me, so I'm not like misleading someone. Then we have the task that is really related to coreference, is the task of anaphora resolution. And sometimes these tasks interlinks, sometimes they are different. Anaphora, it is an incomplete sentence. I'm not sure if I say it correctly in English terms, but this is the case, especially in Czech. It's hard to explain it in English. That you don't see the antecedent in the sentence. It is not mentioned. It is implicit. I cannot now give you the example in English, but we will have some examples later on in the presentation in Czech. So we were motivated really by the practical need to use coreference systems. Like a year ago, and when we did some research, there was no such a system for Czech language available. So we decided to build one for ourselves because we needed a good representation of a single sentence. We created a single sentence encodings, and when we wanted to create a good representation of single sentence, these coreferences and these coreference relations, they gave us trouble, especially the anaphora expressions, because when there was some pronouns, we were unable to correctly make representation of the sentence. So that was why we started looking for some systems that are available for coreference resolution, but by the time we found a first version of the CorefUD dataset, and that was when we started experimenting with it. Just like our task or our goal wasn't to create a completely new system, it was rather a quick experiment where we tried to find out how these multiple languages, when they are combined together, whether they can help with the coreference resolution task on some smaller data sets. So it was our research goal to find out whether the harmonizing of this data, whether it helps with like single language tasks. So there is the reference to the dataset. I think you know it all very well. It contains 11 languages. And there is the reference to the paper. There's very detailed and good analysis and even very good explanation of coreferences in the paper. We took a subset of data sets for our initial experiments. It was the larger models, and we selected a model that is based on clustering. It tries to cluster the relations between words, and if the words like relate to the same words, they are like making one cluster. There are these sizes of the corpora we used in terms of documents, sentences, words, and there are some special cases like empty antecedents. Am I correct, Ondřej? Empty nodes, they're like, but they're the same, right? If the antecedent is not in the data, it's the same. Okay, maybe Ondřej will explain it later on. There are also singletons and discontinued mentions, and I will like explain these terms later on in the presentation. Yeah, one reason or the model we used, it was motivated by the properties of the data sets. In the data sets, these singleton nodes, they were not annotated in all of them. In some of the data sets, the singletons were missing. And in some like data sets, the percentage of singletons was pretty low. So we were unable to really rely on the singleton annotation. Maybe I should explain what is singleton right now, because it will be better. A singleton, and maybe we have better guys to explain it. So maybe please correct me if I am saying something wrong. But singletons are some expressions that may be part of coreference relation, but in the case you see that there is no coreference relation actually. So this is just if we are trying to find out mentions. This is a potential mention that will have in many cases, or in all cases, they will have a coreference relation, but in current document we see there is no coreference relation. It's just like for finding these expressions that will have coreferences, these mentions, these units of text that will be like linked to another units. So this is like if you have the coreference resolution tasks, you can split it into two subtasks. The first task is like finding the mentions, which are the entities that are linked together. And then you have the coreference relations that you are looking for these coreferences. So you can split these tasks, and like first one task can be like looking for the singletons. And if you have data sets where the singletons are consistently annotated, then you can really rely on them and use this approach where you first look for the mentions for the singletons, and then you look for these relations. But in some other data sets, you see that there are too little. For example, for Russian, there is way too little of singletons, and this means that you have only annotated the mention only if it is part of the relation, coreference relation. So you cannot rely on singleton annotations. Therefore, we decided to use a model that doesn't need to see this singletons annotated separately. But we also show experiments where we try to model the singletons later on in this presentation. Okay, wrong computer. Okay, this is a data set that should be, this is a slide that should be related. Oh, no, okay, this is okay. So our model is based on an end-to-end coreference resolution model. There is the reference to the paper, but actually the link of the references, it goes back to 2017, because this is the original model was invented in the 2017, and in this paper it was only like modified for the BERT approach. Correct, hopefully yes. So it models the probability of antecedents in a document, and it uses a score, a binary score that says how a mention, which is here annotated with I, is related, or how well it's related to some antecedent. So you are like modeling a score of similarity or a relation between two mentions. It is modeled as a softmax. So you go over all possible antecedents. If you have a mention, you iterate for all possible antecedents and you select the one that is most probable. Yes. Okay, maybe now it's good time to say what are all possible antecedents or all possible mentions, because we iterate through these items. In this paper, we don't know, in this model, we don't know what are the mentions. We don't like try to find them in some like other approaches, two-phase approaches. We don't try to find them. We use an end-to-end approach that jointly models the singletons and the relations together, or the mentions and relations together. And since we don't know what is a mention, we generate all possible mentions in the document. So we say that, for example, we have every word that is a possible mention, every 2 consequent words are possible mentions, every 3 consequent words, and so on. And we have some limit, for example, I think 10. We have like, we consider up to mentions up to 10 words in sequence. Okay. So there is the formula of how many possible mentions are in a document. And the same is for antecedents. We use the same approach for every mention can be also an antecedent. But here we consider only antecedents that are left to the mention. We don't like model. Maybe this is called somewhat different in coreferences, but a coreference can be also to the right, but maybe it's called differently. This is a rare case. So the central part or centerpiece of the model is the scoring formula. It uses a binary and unary score. The unary score, it models the probability of some sequence of words being a mention or being an antecedent. There are different networks that model it differently. And then we have one binary score that models the relation between a mention and an antecedent. Because we want to allow the model to also say there is no such a relation. This is a mention that doesn't have an antecedent. So we have a null antecedent and it's set to 0. So if the model produces negative scores, then the highest value is 0. And the model says, okay, there is no coreference relation related to this mention. Yeah, and we also used like these contextual embeddings from BERT-based encoders. We have like different pre-training and different corpora. I will tell you, it's like multilingual BERT and Slavic BERT. This is just BERT architecture trained on different data, not English. In case of multilingual BERT, these BERT architectures are trained on like 150 languages or something like that. A lot of languages from Wikipedia pages. And Slavic BERT is trained on some like Slavic languages, I know 4, 5, 6 or something like that. Slavic languages. So these are these encoders. And on the top of these encoders, we use a feed-forward neural network. And we do not freeze the weights, so we also update the weights of these BERT encoders. Yeah. And this is the final part of the model where we produce this loss function. So the probability of the document, it is a product of the probability of the argmax probability of the all antecedents for all the mentions, and the loss function is modeled like according to this overall probability, where we also only put in the model the gold antecedents. So the model is not like discouraged to mark something that is not a mention, just only because it's not in the coreference relation. So we like use only gold antecedents in the loss function. Yeah, so it maximizes marginal loss likelihood of all correct antecedents. So now I'm getting to the results. It's the CorefUD 0.1. We selected a subset of only 6 languages, this largest one. And we use the evaluation metric for this was a shared task, right? Konopík 2012. And yeah, our goal was to find out whether we can join the data sets together and gain some performance gains or some accuracy gains. We also show some monolingual experiments, and we also focus only on the Slavic family of languages and see whether like if you just join together only one language family, whether it helps, it's better than like mixing all the languages together. And use Slavic BERT and BERT as encoders. And here are the results. So if you look at the monolingual experiments, for example, for Polish, German, and Spanish, and you don't see the last language. I don't see it either. It's Catalan, so it's some dialect of Spanish, I guess. So these results are pretty low, and the combined models actually improves the results substantially. So you see some like very nice gains of performance if you join the models together. So I think we prove that like producing this like harmonized annotation, it really helps. The model gains performance and accuracies, but the results are not so well. And that is, I think, Ondřej, please correct me if I'm saying something wrong. But I think the main reason, you will see it later, is that this evaluation metric, it also scores singletons, right? And our model was not modeling singletons. So the main reason for the slow scores are singletons, and you will see later on in the presentation where we remove the singletons from the evaluation, and then the performance is really rise. But I think the important notice is that if we focus on like joining the models together, the performance increase is significant. So it does make sense to annotate coreferences, these smaller, the models can benefit from each other, and if you join these models. Yeah. Okay. So as I indicated in the previous slides, there are problems with singletons. These are mentions that are not present in any coreference relation. And yeah, the singletons are not necessary for these end-to-end systems, but there were some, like in the past, there were some models that relate on, they were like into phases, as I said in the beginning. First, there was the mention identification phase, and in the second phase, there was the coreference relation phase. So the model doesn't predict singletons. That is the reason why for these like languages, they contain a lot of singletons, the performance goes down. And the model, as I explained it, it iterates only for some consecutive sequence of words. And if there is a split antecedent or discontinuous mention, this is a mention that is split with some words that do not belong to the mention, then as an example, then the model is not able to predict it. So these are the main reasons why the performance goes down. We tried to model the singletons because, as you saw in the table, for some languages there was a lot of singletons, and we thought that by like modeling singletons, we can boost the performance of the models. So we try to modify the model to predict singletons as well. But I'm sorry, I'm like talking about a different slide. Okay, this is the okay. This is another issue that is found in the data, and it's about empty nodes. And empty nodes, this is a special case for Czech language, as I promised you in the beginning of the presentation that there will be some like some topic related to Czech language. So I'm not able to, maybe some of us can help me, but I'm not able to translate it or use it in English. But if you have Czech sentence, máme zaměstnance, které občas vysíláme na služební cestu. So we have employees, and in Czech we don't say we. We have just like have employees, and the we is implicit in Czech. And if we want to, in this case, we have two V's. We have employees which we sometimes send to some trips. So, and if you want to find the coreference relation between the we, then in Czech we don't have these words in the sentence. It's like they are not mentioned, they are implicit, they are hidden in the morphology of the words. So we need to add them like virtual nodes in the data. This is the problem for the model, because when they are added and it's like some symbol, then the like relationship modeling between these symbols and real words it was not present in the pre-training of these models, and this makes problem for like creating the representation of these words. And like if the meaning of these virtual empty nodes, it can be derived from the trees, but in our model we don't use any tree information, so we have problems. And also the problem is that currently in the like evaluation task or in the data, these empty nodes, they are like artificially added to the data, but in real world use cases, the model needs to predict these empty nodes somehow, because otherwise it can find coreference relationship between these words. I don't know what languages do use these like implicit, but I think the Slavic languages or morphologically rich languages will have these issues. So currently we use the gold empty nodes that are already inserted in the training data or evaluation data. Okay, it's not very excellent sequence of the slides, Ondřej, but no problem. Here we, as I promised, we noticed that there are problems with singletons, that they decrease the performance of the models. So we remove them from the evaluation, or even the training. We don't have to remove them from the training because the model ignores them anyway, but we remove them from the evaluation, and the performance really rose up, and the monolingual performance is much better now. But still, we can see that except for Czech, that combining the data sets together, it still helps even if we remove the singletons. And for German, it helps like a lot. And for some other languages, it is also very significant. Except from Czech, because Czech is a very large corpus. So the benefit of adding other languages is not so significant. Also, it was even a little bit worse adding the other languages to the Czech data. Okay, this is I said that we also I was talking about singletons, and this was my mistake because I was explaining different slides. So this is the slide I was explaining. We try to tackle the singletons, and we try to modify the model so the model also predicts singletons. And we still wanted to keep the end-to-end approach, just to modify it a little bit so it notices the singletons and try to predict and learns from them, because you see in this previous slide that for example, for Catalan or German or Polish, you have like a lot of singletons. This is like 82% of mentions for Polish are singletons. So these are like not correct. Okay, maybe we can have it to the discussion. But I think this is our analysis, maybe with some mistake, but there was like 82% of singletons. So it means that 82% of mentions are not in some coreference relation in the Polish data set. So the model loses a lot of opportunities to learn how to find mentions. So we try to also model those singletons, so we improve the results. And there are some like ways how to do it. We added another artificial antecedent. So we have the null antecedent. It means that there is no coreference relation. So we added another one, another virtual antecedent that we called dummy antecedent, and it says it is a mention. There is also no coreference relation, but this is a mention. So the null antecedent, it says this sequence of words is not in coreference, and also it is not a mention. But this dummy antecedent says this sequence of words is not in a coreference relation, but it is a mention. So this is a different, we added a different token, artificial token. And also for this token, we discarded the binary scores because they doesn't make sense when you cannot compare something with these dummy representations. And again, and also we added a separate dense layer for singletons. So the mentions can be predicted with a separate layer. But as you will see, it is still end-to-end approach. And in the loss function, we switch with this, we switch with this parameter if the model, if the mention is annotated as a mention in the data, then we compute the positive probability, and if it's not, we discount the score. So there are mention model. Didn't I skip something? No. Okay. So there are these two approaches when we added dummy antecedent and when we modeled the mentions with a separate layer. So you see two approaches, and actually we have to conclude that maybe it helps a little bit for German, but it is a small, very small data set. So it helps because it can the model can learn from these singletons, but for other data sets, we have to conclude that these modifications are not effective. It seems that the model has enough data to learn the mention, even if we discard all the singletons. So we try to, but unfortunately sometimes the research doesn't go as you plan, so we have to like abandon this, and we will keep. Maybe we will only present it to you, but in no papers, because these approaches work only for German, and maybe if we add some other small corpora, we also will gain some good results. But I think when we join the models together, it will be more effective than like predicting singletons. So this is only that we try to do something with the singletons, especially if you have like 82% of the data. So we try to use them as for German. There is a lot of singletons. Yeah, and as you see, there is only 176 documents. So the dataset is very small and it contains a lot of singletons. So we have a proof that our modifications may work, but only if the datasets are very small and contain a lot of singletons. Otherwise, the model is probably still works well with the singletons that are in coreference relations and doesn't need to additional training data. And if we like try to model it, we even spoil the results a bit. Yeah, and the last part of the presentation, it deals with like the almost released Coref 0.1 dataset, or we run the experiments for all languages now, so you will see the results for all languages, all 11 languages. It is the baseline coreference resolution model for the shared task on CRAC 2022, and it is evaluated with the same metrics that is based on universal anaphora scorer. So it's a different evaluation from the previous tables you saw, and maybe you saw already some presentation about the CorefUD. So there is like the annotation is based on head nodes. So if you have you annotate the coreference on heads, and it means that all the words that are like covered by the head, they are also part of the coreference relation or part of the mention. Okay, so here are the results, and yeah, you can there's a lot of numbers, and you see it range from almost 70% to 55%. And we have to say that it's the really basic model. Currently, we don't like, so not to discourage the participants, we don't join anything together. These are only monolingual models. We do not model the singletons. We throw away the singletons, but it doesn't matter for this evaluation metric because the evaluation metric also discards them. But they are presented in the data. They are present in the data, so anyone can try to extract some information from the singletons. And yeah, there are some empty nodes. And discontinued mentions. This is currently hidden. I will try to move the panel, but there is not a lot of them currently. But there is some like room for improvements. If a model tries to predict the discontinued mentions, it can really gain some advantage over the baseline model, which simply fails because it treats mention as continuous sequence of words. Yeah, so these are like some conclusions. So we did some pilot experiments on CorefUD. We proved that the knowledge is well transferable between languages in these harmonized annotations. So I think it makes sense to harmonize annotations. It's difficult and costly to annotate a lot of corpora, and I think if we can join the effort together, it is a good idea. Obviously, it helps, especially for the small data sets. And there are some open research questions. For example, there are some like, we want to deal with zero-show transfer. So example, try to predict the coreferences on languages we don't have any training data. We want to incorporate discontinuous mentions in the model. We want to improve the empty nodes, like predict the empty nodes. Currently, we also can include other big monolingual language, English language datasets, and try to gain some like knowledge and data from this datasets that are not part of this CorefUD. There. Yeah. There are some datasets that have a lot of singletons. They have some datasets have empty nodes, some don't have. So maybe we can, like, in better studying the differences between datasets, we can fine tune the performance on them. And I don't know what you meant by the last point. So maybe Ondřej will explain what is the effectiveness of the model. So I think this is the end of the the presentation. So thank you for your attention. And if you have some question, I think we will have to I will have to run with this microphone. But do you make it work?
What is that